Howdy, 8th grade. Today we are doing lesson 29, which is going to be on a wonderful thing that is called solving literal equations. So what a literal equation is, just so you know, before you start solving, it'd be nice to know what they are. A literal equation is going to be an equation with more than one variable. So some examples of this might be y equals 2x plus 3, or we could have z plus y plus 7 equals x. So as long as we have more than one type of variable, it is a literal equation. So what we're going to be asked to do here is we're going to be asked to solve for a variable. So solving for a variable, and what that means is we want to get that variable alone. I'll show you all an example real quick. That should be pretty easy. We are going to do 2x plus 3y equals 10, and I want to solve for y. And once again, that was 2x plus 3y equals 10. So my goal here is to get y by itself, because I'm solving for y. So this y is being multiplied by 3 and added by 2x. I'm going to draw my line down the middle. I want to start by subtracting 2x from both sides. After I subtract 2x from both sides, these are going to go away because they are inverses of each other. They cancel out. I'm just left with 3y here equals, on this side I have 10 minus 2x. This y still needs to be divided by 3, so I'm going to divide both sides by 3, and I'll end up with y equals 10 minus 2x divided by 3. Division distributes just like multiplication does, so I'm going to distribute that in. The 3 needs to go into both of these, and I get y equals 10 divided by 3, I'll leave that as a fraction, minus still have, and 2x divided by 3 is what I have left. So y would equal 10 over 3 minus 2x over 3. And that would be all the way simplified. There's nothing else I can do to it. So that right there would be my answer. Let's try another one. This is where algebra starts to get really weird and look a lot different from all the other math you've done, because these answers are going to look really, really hideous, but that is okay. So we are going to do a very strange one now that is going to be 4p plus 2a minus 5 equals 6a plus p. And I can divide that straight down the middle. What I want you to do here is I'm going to say solve for p. So in my example, I'm looking at this, I know I need to get p alone, and I notice I've got more than one of them. I've got a p over here, and I've got a p over there, and that is not good for me, so I need to get rid of one. I like to get rid of the smaller one. That means we don't have negatives, so I'm going to do that. I'm going to subtract p from both sides. After that, I have 4p minus p. 4 of a thing minus 1 of it is going to be 3 left. So I have 3p plus 2a minus 5 equals, and on this side I'm just going to have the 6a left. But I need to get p alone. I've only got one of them now, which is nice. And it has this 2a and the 5 hanging out that are both doing addition and subtraction to it. So I want to get rid of those first. I'm going to start by subtracting 2a. After I subtract 2a, I'm left with 3p minus 5 on the left there, and 6 minus 2 is 4, so I have 4a on the right. Now I need to add 5 to both sides. After I add 5 to both sides, it's going to be 3p over here equals, and on this side 4a plus 5. All that's left to do is divide by 3. Remember, when we divide and multiply, it has to be to the whole side. That means I have to divide every part of that right side of the equation here. The whole thing has to be divided by 3. So over here I'm going to have p equals, let me draw the line all the way down so we keep that there. So I'm going to have P equals, silly pen, P equals, and on this side I have 4a divided by 3, would be 4 over 3a plus 5 divided by 3, which is 5 over 3. Just like that, I'm done. If you didn't catch this step, what happened? I took my 4a plus 5, I'm going to do that over to the side here, 4a plus 5 divided by 3. I distributed the 3 into both of those. So 4a divided by 3 is 4a over 3 plus 5 divided by 3, which is 5 over 3. Just like that, I'm good to go. We are going to do one more kind of funky one, and then we are going to be done. I want to show you all why this is a really nice thing to know how to do. So we are going to convert from Celsius to Fahrenheit. So I'm sure we've all heard of temperatures in Celsius and had no idea what they're talking about. That's what they use everywhere but America, because America is stubborn and weird. So I'm going to say that the temperature in Celsius, which is C, is going to be equal to 5 over 9 times the temperature in Fahrenheit, which is F, minus 32. So if I'm given a temperature Fahrenheit, I can plug it in and I will get the temperature in Celsius. I just plug it in for F, do the math, end up with Celsius temperature. But I want to be able to do it the other way around. So I'm going to solve for F. So I need to figure out what I can do here to get F by itself. Now, doing my reverse PEMDAS or SADMAP, the first thing I have addition, but it's inside parentheses, so it's going to be way down here with the P. The first thing I have to take care of is the multiplication and the division, which is the 5/9 here. That means I have to divide both sides by 5/9 and divide by 5 over 9. But we know, because we know how to divide fractions, that's the same thing. Instead of doing that, I can do times 9 over 5. And that's what I'm going to do to both sides. Is dividing is the same as multiplying by the flipped version. So I'm going to multiply both sides by 9 over 5. When I do that, I'm going to have 9 over 5c equals, on this side I have 9 over 5 times 5 over 9 times f minus 32. Don't worry, that simplifies. 9 over 5 times 5 over 9 is 1, so that just goes away. Now I just have f minus 32 on this side, so I just need to add 32 and add 32. After that, I'm going to have 9/5 c plus 32 on the left equals, and on the right, I'm just going to have my f left. Just like that, I solved for f. I have f equals 9/5 c plus 32, and I am all done. I would love it if y'all, for me, could do the lesson practice. There's just 5 problems, A through E. Make sure you bring those in, and I will see y'all tomorrow. Have a delightful evening. Toodaloo.